Okay, so today, I guess what I would like you to do is once I photocopy the summary for you as well, we'll go and have a look. I would like you to have a look and just see, yes, checking off. So GeoGebra we're going to have a look at with the software later on. I'll be honest with you, the 3D stuff also on your calculator. I haven't played too much with that, but this would be a nice opportunity to today, as you're catching up on various things, to have a look. If we go down, okay, and we have a look at our 3D graph. Now, some people might not have this on their calculator. I wanted to update people, so at least the color ones should be able to get this on. The ones that don't have a color screen won't have this. And they have said that the older ones are now like not the ones to have. But anyway, you can borrow them from the back if you want to. But you can actually go ahead and you can type. So you can have like lines, planes and whatnot. I've played around sometimes and they didn't look right on my screen. Again, it's a small screen, but it can do simple things like when you're doing some, where do two lines intersect or what have you, you can always check. And we've also got a situation where you can have a line and a plane. So look, it is there. That's for you to have a little bit of a play around. I would really like it if between, I guess now and our double, that you were able to create an account on GeoGebra. And you can go to, you might as well do it now while you're watching. Oh, that's me. My channel. Hello, Lucy. So if you rock the playlists, there we go. Oh, updated 3 days ago. Didn't know about that. That's apparently the most popular video that I have. Not by you people, but that's all right. Somebody asked me to do it years ago and I just thought, yeah, I'll do it. So where'd we go? So this one here, I don't know why it's come up twice. Why have they all come up twice? I don't know. I honestly don't know. But this one talks you through how you can actually create the room. So I will also pop the investigation up. We have talked about it, have the actual task, but we're talking about 2 mosquitoes in a room. Now you can have it, you can be creative. You can say it's your lounge room at home. You can make up your own room. You could do this classroom here. I was lying in bed this morning going, oh, I could be in bed and reach for the can and spray the mosquitoes. That's how sad my life gets, right? But you have to start thinking and planning before we get right into the heart of the investigation, but thinking about what kind of maths you're going to do. Now, we've mentioned this before, but, where are the 2 mosquitoes going? They're going for the same person. Are they going for 2 people in the room? You can have more than one person. But at the end of the day, your task is going to be, yes, you're going to show, oh, look, I can create equation of a line and I can set a specific velocity for it and all that sort of stuff, right? Doing unit vectors and blah, blah, blah. You can show that the lines are skew, they don't intersect, or maybe you're going to choose that they do intersect. That's all cutesy stuff. But the heart of the matter is then going to be that you have to kill them with one spray. Right? So then you're going to go, where are they going to be closest to each other? When would be the best time to do it? Or so you want them to sort of be maybe closest to each other before they hit the targets. That's probably the easiest one to do, because if they don't come closest to each other before they hit, you're not going to be able to do some of that maths. Does that make sense? So yeah, think about things like that. You can have the angle that they make with the floor. So angle between a line and a plane. But then you've also got what happens. I was thinking, oh, what happens if you were lying in bed? Then your bed is flat and you could say, well, that's a specific plane there, or a table or whatever. Yeah? What hasn't, and again, I think I do my best thinking sometimes in the morning. It was that what happens if we know they don't fly in a straight line, but what happens if they do sort of change direction? I don't think anyone's done that. So, and it could be that they go from one wall to the other. Last year somebody did do it where they didn't start at the same time. So one was still sitting on the wall for a little bit. And then, boom, they came into action. So things like that you can start thinking about, that it's not just zoop up. Play around, have a little bit of go. But before you can do any of that, I think it's really sensible that you play with and sign up for GeoGebra, because you can do some of that software there. Okay. As I said, you guys said we talked about, what was it, the fusion thing? The CAD, and that's too complicated. This is quite simple. It's not brilliant, but it's simple. If you do have another software package that you are happy with, by all means let me know. But a lot of people use that one, and that's what was mentioned in the SACE outline. I haven't actually played with WinPlot, but anyway. So back to us. So I apologize if you have wasted some of your time trying to do 15, because well, yeah, it was very much like the example, but sorry, that's sort of vector equation form. We don't need that. Sorry. This one, I would say write this down on a formula that when I give you your photocopied revision or summary sheets, you'll find that that's just on there anyway. And if we go back, I don't know where everything is now. Let's have a look at our outline. I have a feeling. I got a feeling. I thought, oh, there it is. Is that the same one?
Yeah.
Yep. All right. So really, I'd sort of be going, have a go at 18 and 19, where we're just using a formula. Don't even do B. I'd say like A. We're just trying to find the distance between parallel planes. So you take the parallel. How do we know they're parallel? 1, 1, 2, 2, 2, 4. Oh, they're all repeating, but we can do that together if you like. And what cometh next? So again, this is just routine. So again, each bit by itself, I think, is quite nice. So angle between a line and a plane. So bang, there's your formula. Okay, the only thing that I guess people get mixed up about is make sure you use the direction vector of the line, which is your D, and the normal. Boom, 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 boom. Okay, and how do they give you that information? So sometimes they might say, instead of they give you the plane, they might say you've got a line that is perpendicular to the plane. Well, the line that's perpendicular to the plane, the direction vector of that line will be the normal vector of the plane. Do we agree? So little things like that, they just try and, you know, I don't know who they are, but anyway. So, and then we've got the angle between two planes. Again, I mean, without even having to look too far, we can see very easily we've got our normal vector for one plane, normal vector for the other. It's just a straight formula. So this is stuff just add to your formula sheet, your summary page. What I would like to do, so that's just straightforward. And then we've got our solving linear systems, which is the row operations that we did last year. Now, I'm not expecting you to memorize that, but we've got a smile from the crowd, because I think we did like this, the row ops. Yeah, it was nice. So what I was hoping, we got, ooh, let's have a look at that. But I figure maybe we could do that tomorrow. Today, we can finish off any of the stuff from earlier that we have issues with, because that was a long exercise that we were going through. So some of you might need that chance to catch up. And if you don't have a lot of questions, then this might be the time to have a play with GeoGebra. Does that sound like a plan? And Mac, we can sort of just catch up on stuff. Give you a moment. Eden, I know you've been swimming a little hard out. Yes? All right. So unless there's major questions, we want me to do like 18, 19 or?
17.
Okay. Oh, 17 was a bit unnecessary. It's just, is that the one proving the, no. But we can go through that with you if you're really wanting to. But with 17, you're just coming up with a formula, so you don't actually need to do all of that. But if you'd like to do just D using the formula, so, you know, you can suss. Here's your point here. So that would be your point. This is where it hits the formula. I think you're capable now of following formulas. The main thing, notice how the equation of the plane is written, right? So look at the D. So when they give it to you in this form, what is your D?
Negative D.
It's negative 10, okay, not 10. So just little things, just be careful that you're looking carefully and you don't miss that where that equals sign is. All right, here you haven't got a point. You've got a plane and another plane. But because they're parallel, what do you have to do? You can just pick any point on this plane. How can you pick a point on this plane?
Set one of the values to 0.
You could set 1 to 0, right? You could go, what if x was 1, y was 1? What would z have to be to make it 4? Like there's some pretty obvious values. Or absolutely you could just make a couple of them 0. So 0, 0, 2. That's going to be a point on here. What's another one? 1, 1, 1. You could go minus if you really wanted to, but why would you make it complicated, right? Why? Go simple. You could have 4, 0, 0, 0, 4, 0. The list, right? 2, 2, 0. Anyone got another one? 1, 3, 0. Sorry, go up. That's just saying if you can do it with variables, no need. Just while we're here, if we're looking at 19, show that this line is parallel to this plane. How can we do I wanted you to go, oh, parallel, you'd be one multiple, but no. To show that they are parallel, right, this normal vector, wouldn't that be, as Ethan said, wouldn't that be perpendicular to the line? Silence. Are you getting that, or are you just not happening with it this morning? So go back to your diagram, right? If we want to say that here's our plane here, and then we've got a line going across like that, we want to say that that line is parallel to this plane. Wouldn't that line have to be perpendicular with that normal vector? And then how do you show that two things are perpendicular? The dot product, as Ethan said, right? But sometimes people just go, oh, parallel, oh, multiples of vectors. No, you've got to think about what's going on. So if two lines are parallel, yes, their direction vectors are multiples of each other, but this is a line and a plane. So try and see if you can do, I'd be happy if you can do 18A, 19, 20, just using that formula, getting your formulas under control, playing with GeoGebra, catching up on anything that you've missed, making a summary page before we hit, what's it called? Well, investigation, but row ups tomorrow. Okay? Love you.